get started, let me give you some background. I work as a DevOps technical writer at DigitalOcean, so I write some of those tutorials that you see in the DigitalOcean community. I've been a PHP developer for most of my career, so I'm very interested in PHP development environments. I wrote a book called Vagrant Cookbook that talks about how to use that tool for creating development environments. And now I am into Docker Compose, of course. So let's set some expectations about this talk. This talk has three parts. In the first part, I will talk about PHP development environments and how they changed over time, and give an overview of Docker Compose. In the second part of this talk, we will start building a Docker Compose file to create a multi-container environment for Laravel. And in the third part of this talk, I will show a demo. So let's get started. Let's talk about PHP development environments and see how they changed over time. I'm going to share some of my personal experience with this. So when I started around the 2000s, around 2003, 2004, this is how we would do development environments. In PHP, we have the WAMP server or XAMPP installed on Windows, and then we will use FTP for sending the files, and it was okay, right? Around 2010 and around that, I started using Linux only for my local machine, and then I started using a local environment on Linux, and I started using Git, and it seemed a lot more professional. However, it was the era of it works on my machine, because, well, you have a setup that it works like it's very similar to the server, so why doesn't it work on the server? Right? It works on my machine. Around 2012, 2013, I started using Vagrant, and it was a big change. It was a lot better to share environments with coworkers, and you were now able to dispose and replicate full environments and also make them very similar to what you have in production. And also the good thing is that it was very easy to understand, because virtual machines were a old already, like kind of old technology. Everybody kind of knew how to use that or how they work. They are very similar to a regular just full machine. So it was not very complicated to understand that. The cons, it's that it was a big footprint. And if you had multiple projects and you wanted to have them running at the same time, it would be really, really heavy on your machine. It uses a lot of memory, and also it depends heavily on automation tools. Around 2014, 2015, Docker became very popular, and people started using it for development environments. So it has a small footprint, it is very fast and lightweight, and with the images schema, it eliminates the need for heavy automation, because you can reuse so much more and it's so much faster. However, it is not as intuitive as virtual machines. It was not. So it took some time for people to understand how it worked and what was the difference between a container and a virtual machine. And also the other thing that was very hard, it was how to define and manage these services in a declarative way, not like having to run a bunch of commands manually, but instead having a way to easily create these full complex environments with a lot of moving parts, and it was hard to get them together, share networks, share volumes, and all that stuff. So then Docker Compose came to the rescue. So what is Docker Compose? Docker Compose is a tool that facilitates creating multi-container application environments. And you create this on a YML file. So you have a bunch of service definitions, and they can share networks, they can share volumes, you can set them to preserve volume data. You can have a lot of fine-grained settings to have this environment fully working and like connected, all services connected to each other. So this is an example of a simple Docker Compose file, and this will create a web server service. So it's based on Nginx. It starts with the version definition, version 3.7 in this case, and then you have the services. And then we start. We have only one service in this file, web, which uses the Nginx image, and then it defines a port redirection. So all requests on my host that goes on port 8000 will be redirected to port 80 inside the container. And this is important, so then you can access the application from your browser using localhost and all the benefits of that to facilitate development. So these are some of the most common and most relevant commands to use with Docker Compose to manage your environments. First, you have the up and down commands. So we've seen the up command before. And the other thing about the up command is that you can also run it in background mode with the -d option. And the down command will bring your environment down and remove all containers and networks and volumes. If you just want to stop for a moment, and then you can use the stop command. This won't remove any containers and images, networks. It will all be there, and then you can get back to it with a Docker Compose start command. The PS command is like the Docker PS. It will show an overview of all the containers that are present in your configuration and the status of each container. The logs command will show the logs for all your services that are currently running on that environment. The top command will show the active processes, and the kill command can be used to kill a container. The exec command is also very important, especially for our use case with Laravel, because while developing we always have to run artisan commands or composer PHP commands. So it is important that we have the ability to run commands inside the container with all the context and the database and everything that is that you can only have from inside the container. So it's important to be able to do that, and the Docker Compose exec command allows us to do that. Okay, so we have seen an overview of Docker Compose and the commands. Now we're going to go to the second part of this talk, where we will examine a Laravel demo application called Travelist, and what are the needs, the specific needs for this application to be containerized using Docker Compose. So this is the application. It is a very basic demo Laravel application. It uses a MySQL database to store places and mark them as visited or to go. So what are our environment needs specific to PHP? We need a web server, and we are going to use Nginx. Then we will also need PHP FPM to process PHP code and bring it back to Nginx to be served. And we also need a MySQL database to store the places. In terms of Laravel, specific Laravel needs. We have some PHP extensions that we need to install that are required by Laravel. We also have to install Composer PHP, the dependency management tool Composer. And we also need to be able to run artisan commands inside the application container. So how does that translate into containers and images? In terms of containers or services, as we were going to call them, we have the Nginx service. We are going to have a service called Nginx, and it's going to be based on a pre-built image from Docker Hub. The MySQL service is also going to be based on a pre-built image from Docker Hub. And in the case of the app container or service, this is going to be running PHP FPM. However, we need to install a few custom things, a few custom PHP packages, as we mentioned before, that are required by Laravel, and we also need to install Composer. And for that, to run Composer, to run artisan commands, we will need also a system user that is a regular user, so we don't run this as root. So we will need to do a few customizations. So we are going to build a image from a Docker file for the app service. We will need to share some volumes. First, we need to share the application files naturally, and this is going to be shared from the host to the application and to the Nginx services. Both will need to have the application files. The Nginx configuration file will also need a specific dedicated shared volume, so we can share a configuration file from the host machine to the Nginx service. And the MySQL service will also need a database dump, a shared volume so that we can share a database dump. This is going to facilitate development because then we can initiate the database already with a database dump. This is a feature from the MySQL image we're going to use. We'll also need a shared network between all the services and the host machine. And that is all. That is all we need. So now we can go ahead and start setting up our Docker compose.yml file. So this file is usually at the root directory of your application. And this is where you are going to configure all your services. We've seen a basic example before. And now we're going to see each service separately. So we will start with the app service. The app service will use a custom build based on a Docker file that is specified in the Docker YML, the Docker compose.yml, in the Docker file option. These are all under the build directive, so it contains the context set as the current directory. We are gonna build this as an image called Travelist, and we are naming the container as Travelist-app. We're setting the restart policy as unless stopped, which means the container will always restart unless it is stopped manually or otherwise. The working directory for this service is var www, which is where the application is located. The application data, the application files are located in this directory, as well as in the Nginx services, so they share the kind of same directory to facilitate understanding where the files are in each container. And then we create a volume here. So we are saying that the current directory, we are sharing it as the location /var/www, which is our working directory where the applications files are. And then we define that we are going to use the Travelist network. So this is going to be present in all other service definitions as well. So they all share the same network. So this is the definition, all the definition for the app service, but we are still going to see the Docker file for this image. Next, we have the Nginx service, and then you can see that we are now using a pre-built image from Docker Hub. So we are going to use Nginx Alpine image. We're going to name this container as Travelist Nginx. The same restart policy, and the other thing we have different here is the port redirection. So it's the same as we saw before with the simpler Nginx example. We are redirecting all requests in the host to port 8000 to port 80 inside the container. So we can access this web server by browsing localhost 8000 in our host machine. We are going to share two different volumes. So first is the application files, also similar to the same as in the app service. We are going to share all the application files to a location /var/www inside the container. And we are also creating another volume to share a configuration for Nginx, a server block configuration. So we are going to have to create this directory docker compose Nginx and have the configuration file there. So it's going to be shared in the confd directory in the Nginx configuration directory. So finally we have the networks definition, using the same network as the app service. And this is all the Nginx service definition. Next, we have the database service, DB service. This is going to use the MySQL 5.7 image, pre-built image from Docker Hub. And we're going to name this container Travelist DB, the same restart policy as the others. And what is different here is that we are defining some environment variables. So this is a feature from this specific MySQL image. So you can define some environment variables, and then when the image is started, it will already create a database in the user in this database for the application. So what we are doing here is we are obtaining these values from the .env Laravel file. So the .env is a file that is in all Laravel applications. Use this file to set database settings and other services and credentials. So we are obtaining this from the .env file from Laravel, so from our application. So all the values, the credentials that we set up in the .env file will be automatically obtained here and inserted as environment variables in this image. And then you will have magically created a database and users for your application. The next part is so the volumes definition. We also have a special volume to share the database dump that we want to be imported by the image. This is also a feature from this image. It's going to be automatically importing any SQL files that you put inside the directory called docker entry point initdb.d. Yeah, that is all. There was all of our services definitions. So we have defined an app service, an Nginx service, and a DB service. But as we've seen, the app service uses a special Docker file, a special image built with custom things. So we have to build this Docker file now. So our Docker file is going to be based on the PHP 7.4 FPM image. We start by defining two variables with the arg directive. So we are going to define these variables so we can create a user that has the same UID as our current system user on the host. This will facilitate managing files, creating files with the artisan common composer, because whenever you create files inside the container, then you want these files to have the same permissions in the host machine, because you will be working from your code editor in the host machine with the shared files, including the files that are created from inside the container. So you need the right permissions there. The first actual instruction we have here is apt update, and also installing some packages that's going to be needed, required for Composer, for Laravel. So we have some basic packages here. These are system packages, and then in the continuation here we will have a cleanup. And then we'll install the PHP modules that are required by Laravel. So there is this Docker PHPX install utility that we can use, and these are the required PHP modules that we need to have installed for Laravel. And then we will create a system user. This system user will have our same UID, so there are no discrepancies in permissions and file permissions when a file is created inside the container from Artisan or Composer. So we have the user add command, and then we create a user directory, a home directory with a .composer directory as well, and set the permissions for this user. And next, and finally, we install Composer. This is an easy way to install Composer from a Docker file, just by copying the Composer executable from the latest Composer image from Docker Hub, and then we copy this to our containers USRB Composer, so it's installed globally. Then we finally set the working directory for var www, because when we are going to use the Composer exec command, we want it to be in the right directory when we run these commands, the artisan and Composer commands. And last, we change to the new system user. So when you run the commands, also you are going to be running this as the new system user we just created. And now we can move on to the demo part and see all these in action. I'll start by downloading a release from the Travelist Laravel demo GitHub repository. We want the 4.03 version, which contains an updated database dump and the Docker Compose files that we've seen in the slides. So let's get this. And I'm doing this to simulate how a new user would get your application up and running from scratch. Unzip this, and then let's rename this just to make it easier. Okay, so So we have all the Laravel application files, and we have here the Docker compose.yml, the Docker file you've seen in the slides, and also the Docker compose directory with the MySQL folder that contains the database dump, and an nginx folder with the nginx configuration file for our host for our Laravel application. And before we can run Docker Compose app, we have to set up a .env file for the Laravel application, because this file doesn't come, is not included in the version control. It's a file with sensitive information that shouldn't be version, and it should be a per environment file. So usually you have a .env example file that you can copy. So I'm not gonna change anything here. These are all default development values. We have the database settings, and this is the important portion that Docker Compose will need, because Docker Compose is pulling from the .env file to set up the database service. This will create a new database user also in the database for the application. So now we can run Docker Compose app, and this will create the containers and start all the services. You will see a lot of output here from the logs, especially from the database service, and it will create a entry point sharing, and it's running here. You can see that it run the initdb SQL dump file. So the database should be set now, and so it's a lot of information. And now we have to run a few other commands so that we can open the application from our browsers. You have to set up an application key. We have to install the application dependencies with Composer as well. And we can do that using the docker compose exec command. So we're going to run these inside the container. Docker compose exec app, because we are going to run this in the app container, in the app service. And we need first to run composer install. So this will install all the application dependencies. And if you have used Vagrant before with synchronized folders, you will know that this is a lot faster than using virtual machines with shared folders. So even though it will take some time, but this is just on the first time you get the application up and running, so you have to run composer install. In the first run, it's going to take a little bit more time. Once the vendor folder is created, because the synchronization happens in both directions, you don't need to run this command again. So just on the first time, and you only need to run composer if you have a new package to be installed or to update the packages. So it's only in the first run. When the composer install command is finished, then we have to generate the application key, and for that we're going to use the artisan Laravel command. So the things that we need to do once we get the files, just to recap. So once you download the application, you have to create a .env file for the Laravel application, and then you have to you can run Docker Compose app. Once you have your services, your containers up and running, then you can start running the commands that depend on the database and on the application in the command line. So you can install Composer, and then you have to, what we're going to do now, we're going to generate the application key. So we're going to run PHP artisan key generate. So the application queue is set. Now we can, if you have database migrations, this is the time to run the database migrations as well and seed the database. We have those, but we don't need because we have used a database dump to get up and running faster. So let's see if the application is up and running. Let's check that. Yes, so it works. The application is up and running already. Everything works as expected. Well, this is it. I'm finished, and I hope you have enjoyed this talk. Thank you very much for watching till the end, and if you have any questions, feel free to